I'm used to the meeting. I'm used to the meetings being automatically recorded.
You live in the future.
All right, and this talk is largely inspired by Luke's presentation at KubeCon Wazn Day last year at Detroit. The talk name is The Path to Components. So first question is, why are we putting Wazn in production outside the browser? Why are we interested in WebAssembly system interface? Well, there are some obvious reasons, like Wazn being language agnostic. Wazn is open, formally defined, and it has a portable standardization. And most importantly, it has built-in sandbox-based security models. So two Wazn modules running in the same runtime cannot access the memory of each other. It's actually literally verified by the runtime by inserting checks into the linear memory boundary of the Wazn modules. And we also think that Wazn provides a very good use cases for smaller computes abstractions from we go from virtual machines to containers to even smaller binaries like Wazn. And we think Wazn is very important for serverless computes as well. However, there are some pain points when using the Wazn modules. The first pain point is if we have multiple Wazn modules that want to do some interoperations between them, we literally can just use very basic pointer types like I32, I64. But if we want to pass complex data in between the Wazn modules, we have to do them as unstructured text like JSON or other serialization formats. So one way of solving this is to introduce more high-level value types like strings, lists, records, variants with subtyping. And this is what weight is coming from. I'm going to show you a weight example later. A second pain point is when we link Wazn modules. Static linking, we have to allow the Wazn modules to access the file systems. And that's what Dan Goleman calls like a ghost, because accessing a heavy file system sometimes introduce conflicts or sometimes just getting undesired results. So instead of doing static linking, component model allow us to do parametric linking and dynamic linking. So basically how it works is that it allows one component which has statically defined types. And if you want to introduce states and dynamic things, you have to instantiate a component into an instance. And that instance have all the changeable states and things like that. And what's cool about that is a Wazn component can instantiate another component to form an instance of it. And basically that allows you to form a dynamic instance graph that can be deployed. That's super cool. So that's basically the gist of it. First thing is it has high-level types, and second thing is dynamic linking. And Wazn component model is a standard. It's a binary format built on top of the core Wazn specifications. And this is the link to check out the component model repo. It has high-level explainers, the weight IDL syntax, and the canonical ABI explainer for the component model. You can read all of them there. But the high-level idea is that the component model defines a portable, load and runtime efficient binary format for separately compiled components built from WebAssembly core modules that enable portable cross-language composition. And they also support the definition of portable, virtualizable, statically analyzable, capability-safe language agnostic interfaces especially those being defined by WASI. And I mentioned the word WIT, and WIT is an interface definition language for the component model, and it uses some high-level types like those I mentioned: string, records, variants, and the syntax is very much not like WASM syntax. WASM has a bunch of like braces and things, but this interface, it's much more, I would say, human readable. So this is defining a key value interface, and in the key value interface, there are get, set, delete, and exit functions. And there are some code generation tools like WaitBindgen that takes a wait file and can generate a guest binding for your guest language. Suppose you're a Go developer and you want to write Go applications that targets this interface. WaitBindgen Go is doing exactly the thing that generates the bindings to lower the high-level Go types into WASM types, or lifting low-level WASM types into high-level Go types. And how it's being lifted and lowered is defined in the component model API stack. There is also this concept of words. A word is basically imports and exports a bunch of interfaces to become a whole capable unit of code. So here we have a command world, and this command world imports console, the file system, socket, and export a main function. So this is your normal Linux executable. On the other side, we also have a more serverless style of word called proxy world. And this proxy world is basically doing a HTTP proxy that imports console upstream configuration and export a single HTTP handler. And in the WASI standardization, we have a bunch of interfaces like sockets, file system, man, login. And what's cool about words is that they can choose grab the necessary interfaces for imports and exports and bundle them together and use some tool like WaitBindgen to generate bindings for the application. And there are more resources. You can read about the component model. That's my 5 minutes of introduction to it.
Thank you, Joe.
Can you share links? Yes, of course, I can share links. Do we have any questions?
I have a question. So in the example of bundling together a number of components or APIs under a world, so let's say for Go, would a Go program target a world explicitly, or would generating bindings for a world generate, say, bindings for individual interfaces, which could result in packages that could be individually imported and then linked against?
It's usually just targeting a word at this point. So when you target a world, you have to provide, as a host, you have to provide implementation for all the imported interfaces. As a guest, you have to provide implementation for all the exported interfaces. You don't have to necessarily use all the, as a guest, you don't have to use all the imported interfaces, if that makes sense.
Right. But I mean, hypothetically, a number of those interfaces will be implemented, say, by the Go standard library, maybe say some lower level aspects, and then other parts could be implemented as third-party packages. How do you end up seeing the delineation between the two?
So do you have like a word in your mind that you want to discuss, like a CLI word, for example? I would assume all of the imported interfaces are implemented in the standard library. But there is another world like proxy world, which is showed here. Imagine like handler, config, and upstream can be implemented by third-party libraries instead of standard library.
Can a WASI guest require more than one world to operate?
No, just one word is enough.
Got it. I guess I'm just curious about like the disjoint set. So like, say you want to implement a proxy, parts of like say the proxy API, but your proxy API is also making, say, socket connections, which would require, say, WASI sockets as well, but that's not available in the, like, say, the WASI proxy world.
That's it. That's a good point. I think like for a proxy world, it's all virtualized. The sockets API are not exposed to the guest at all. So from the guest point of view, it only require those imports, and how those imports are being provided by the infrastructure or by the host is irrelevant or transparent to the guest. The host can choose to use like sockets APIs to provide the implementation of the proxy. If that makes sense.
Yeah. Okay. Thanks. Thanks for the explanation.
So is it to maybe speaking Go words? Is there a parallel between this import console? Does that WASI logging / backend? That's another world, is it?
Oh, import is a interface.
Okay.
Another syntax is called include. It's for words.
Yeah. So can you import worlds?
No, you can't. You can only include world or import interfaces.
Okay.
And by the way, this proxy world is a bit out of date. However, there is a WASI HTTP proposal under a WebAssembly organization. And this is the proxy world that being standardized. So in this proxy world, we have clocks, random, standard out, standard arrow, standard in, an outgoing handler, and a exported and incoming handler.
Okay.
Just to make my question, sorry.
Just go ahead.
Oh, I guess to make it more concrete, like let's say hypothetically you have like a something that would use the WASI HTTP world to react to incoming requests, but that program needs to be able to make arbitrary socket requests. So it would have to, as I understand it, union together it would have to import WASI sockets, but also import the WASI HTTP, and then how would that end up like working, I guess? Would that require WIT bindgen Go to generate bindings for everything, including what's already implemented in the standard library, in addition to the WASI HTTP pieces?
If I understand correctly, you're saying a component that targets both WASI sockets and WASI HTTP. Is that right?
Sure. Yeah.
Or are you saying the implementation of YZHP is from YZ sockets. So from just by looking at this world, a component targeting YZHP have no knowledge of YZ sockets at all. It's completely transparent of how the host is providing sockets API to enable the proxy world for the component.
Is it okay if I try to answer this one, Joe?
Yeah, go ahead.
So if I show, maybe this is a little stale of a demo, but here is an example of running a Go component. I do use Go generate to generate bindings, but that's not really the main trick here, right? It has imports for those things, but whether or not that's supplied by another component or by the host, I don't really know from this Go program's perspective. And so to answer your question, I included what it looks like to write what this program is. So in this case, I have assembled different critters. Gopher is one of my critters. Other ones are rustaceans. Another one's a cat for C, whatever. It's to show off different languages. And so in this case, I am exporting just a simple function to show round tripping with a string. Take a string and concatenate to it. And so to answer your question, this is where you would have an include of the YZHTTP proxy world, and you would have an import of the YZ socket API. And so once you have that inside your C program, or not C program, your Go program, you would use those imports here. So right now I'm calling the set exports, but the generator will generate the things that I need in my gen folder here. Right now it uses CGO stuff. I don't want to step on what I assume the socket is going to dig into in a bit, but I would have some of these imports generated for me, and I could call them inside my program. So I hope that helps.
That's super helpful. I think my question was more just around the code generation itself, because if you're synthesizing say the world that includes one world and then imports another interface, when you do code gen for that, is it going to basically duplicate code gen that's for something that's already implemented in say the standard library? But that's more of my question.
I think in general, words, and correct me, you Bailey Mosaka, correct me if I'm wrong, but words in general are meant for capabilities that you would implement in your host. I mean, components are wider in that you can combine components, and you could also write your program as a component, and then you could combine those components. But when it comes to WASI, those are basically broken down capabilities, sets of interfaces that would be implemented on a lower level by your standard library. So as a Go developer, you wouldn't really know that you're using, I don't know, WASI sockets, because that will be implemented by, I don't know, TCP listener. Is that correct?
Yeah, I think that's a great way to describe it, is that the Go developer in those cases would be importing from the HTTP module in their program and not some WASI thing. So that's kind of that's also transparent to them because they're building on the Go standard library. Here's another example. If you go and look at how Rust works for some of these, this is the WASI Preview 1 API, but basically when somebody's coding in Rust and they want to get the current time, they still run the Rust current time functions. They don't have to change their code, even though they're compiling to a component or to a WASI Preview 1 module. But what happens inside the standard library is it says, okay, for this API, I've implemented a WASI type for this. So I think the things that you want to say on the import, if somebody's writing a Go program and they have an import that's part of their world, they're basically saying that's that's something I intentionally don't want to be built into my program.
I'm curious about why the world needs to declare the imports.
Why does the world need to declare imports?
Yeah.
A word is a set of interfaces, it's like a module. So it's a set of interfaces. So the thing that is importing is a list of interfaces.
Okay.
This is my understanding, right?
Yeah,
So when
just
you
importing other code, so you can
so,
reuse other code to run.
so if we talk about like wit bind gen for Rust, if you have a world that imports the time API, does it code gen that time API, or does it know that that's already there in the standard library and it doesn't regenerate?
I think let me got your question, Randy.
Okay,
If
thank
you're
you.
using Weight Bindgen is supposed to be like a low-level tool. It's so if you feed in a world that has like imports and export, even though those imports sound like they should belong to a standard library, Weight Bindgen still generates bindings for all of them as of today. So the goal is to abstract away Weight Bindgen by allowing Go developers to use Go tools that they don't have to learn Weight Bindgen at all.
Yeah, I guess that was my question, which is like an application developer saying, let's say like a cloud hosting provider creates a world that couples together WASI HTTP and sockets. And now they've got to generate bindings for that. I guess that would be the role. That would be the responsibility of that provider to provide APIs baked for each target language, as opposed to an application developer compiling a WIT to target.
Exactly.
Okay.
And
the
end goal is developer doesn't use Weight Bindgen at all.
Okay,
Provider should provide.
That's very helpful. Okay.
Yeah, I
Thank
think
you.
we can
Right.
sort of think about like, at the layer of the stack, like the people who are developing Go, the people who are developing like SDKs for a particular runtime versus the people who are developing like the actual handlers versus like the users, right? Like which of
Right.
those people are going to be running with BindGen? And it sounds like it's the people who are basically building the SDKs for like cloud provider kind of people
Right.
that
Right.
will be running this.
Okay.
Is that a fair statement? Yeah. Okay.
As,
Okay,
as
thanks.
far as far as WASI is concerned, and that namespace, that is entirely correct. You as an end user would be able also to develop your own words. So in that case, maybe you might have to run with BindGen, but it's a very specific use case.
Yeah, exactly.
So I'm curious about the export part. So in the world, like the proxy world that you show, there's an export handler. And
Right.
what does that exactly mean?
You can think so whenever we think about those, there are like two perspectives, the host perspective and the guest perspective. From the host perspective, if a world that export a handler, the host is free to invoke that handler, assuming the handler has some implementation provided. From the guest perspective, the guest has to provide implementation for that exported handler. So you can think of in the WASI HTTP proxy world, the guest application is just a HTTP handler that implements only one function, HTTP handler, and that takes in a request, somehow process that request and return a response. That's like a function as a service-ish thing. And from the host perspective, it connects a TCP. It tries to connect the TCP and listen on request. Whenever request comes in, it invoke guest HP handler, and that returns the response, and the host is able to do more about that response.
Okay. So taking the example of I'm writing that handler, it means I'm a guest program. I'm using with bindgen to generate kind of the structure of my guest program, which is going to declare the imports for the things I need provided, and it's going to create a kind of empty exported handler, and I'm going to put my code in there. It's kind of like the idea.
Exactly. Okay. Yes.
Or to use with bindgen to generate a package that another program would just import, and then it would implement that interface.
Yeah, and so it makes a higher level, more Go-like interface to that structure.
Yeah, so
okay,
all of the imports should be in that package that your application is free to use, assuming they're just libraries.
I feel like Damien could comment on this because he has the Fastly one. It's not reactive, but they did have to do this.
Yeah, I mean, we did it all by hand. There's a lot of work. It's like a 3,000 line file, and migrating it from TinyGo to the new WASI stuff in 121 was a Perl script that did all the rewriting for me. I think it would be lovely to have something that would auto generate all that stuff, but for the moment, just do it by hand.
Okay. Joe, do you want to jump into the current development on with bindgen Go and the questions that we want to answer here? Sorry, I didn't mean to cut off anyone. Just want to be cautious of the time we have allocated.
Share my screen. Alrighty. So what you're looking at, oh, by the way, can anyone see my screen?
Yep.
Cool. So what you're looking at is a repo called with bindgen, and we are already discussing this repo. And with bindgen is basically taking those with packages, or a with package is defined as a bunch of with files bundled together as a package. It consumes those with packages and generate bindings for each language. So currently, with bindgen supports C, Go, Rust, and Java, and there are other languages that separate from with bindgen, like componentized JS and componentized Go. But the idea is the same. They take with packages and generate bindings for each corresponding source languages. At the beginning of this year, I spent like a month or two, wrote this Go package, Go crate in Rust, that takes those with packages and generate Go bindings. And the way it works is kind of different from other language generators. For example, for C and Rust, they directly use the component model ABI to lower and lift C types or Rust types to the component types. But in the Go implementation, the story is a bit different. At the time when I was developing this crate, I didn't find a good way to do WASM imports and WASM exports. Like for both mainland Go and TinyGo, there is no WASM exports. But as you know, with interfaces have a bunch of imports and exports. So I chose to use SIGO to generate bindings to core C functions. And where are those C functions coming from? They are from the C generator. And then those C functions are going to do the lowering and the lifting jobs from C types into the component ABI types. So there is a major indirection here. And all of the generation code here looks like just generating a bunch of SIGO SIG source code. I don't know if I can find an example here. As you can see, there are like print C result, print C parameters, and print C function parameters. And this all works, but it's just undesirable. So a major ask in this repo and in one of the issues is to switch the SIG implementation to the component model canonical API in pure Go implementation. And I did have a little experiment with it. So given this host world that imports print and export a run function, I can use the tiny Go's while an import and Go export directories to generate bindings for Go without SIG. So this whole thing works, and I imagine we can apply the same principle to every other types of functions in the Go crate to completely remove the SIG implementation in that repo, but that might take some work to do. So that's one thing. Another thing is I started the ergonomics improvement discussion a month ago, and I have described the problems here. And the major issue with the Go bindings is that Go doesn't have native variance, union, result, and option types, which are present on wait. So I have to do some, I have to use like structured interfaces to represent option and result types. And I feel like those representations are a bit raw. So I started an issue collecting feedbacks, and we got a very interesting and long discussion here.
Do you have a
You want me
quick
to?
summary of what you think was relevant in this discussion, or where it kind of landed?
To be honest, I lost all the context. I didn't prepare too much about this. But I think the major thing, as Randy told me, that because the bindings are so low level that they eventually might go into the standard library, we might prefer more like idiomatic Go instead of we might prefer like more performant Go code instead of idiomatic Go code, because they are not going to be directly used by the users.
Yeah, I would agree with this. I think there's also a, maybe stability is not that important here, because like we kind of agreed that those were, low-level interfaces. They're meant to be wrapped and exposed as, APIs that are, more effectively consumed by the end program. Mm-hmm. So if we do need to change the way the code is generated underneath, that, the contract here is that, this is not what the end program is going to consume. So it shouldn't be a breaking change for the end program, right? It should be a breaking change for the library that uses it. But, that seems, acceptable, considering you also, it's an opt-in, right? You have to update with bindgen and regenerate your code. And then you have to, make the modifications to adapt to, adjustments that have been made. So I would say let's try to, optimize for simplicity and for, performance, which oftentimes, come in. Avoid, too much abstractions, because that tends to, create more problems down the road, especially when we're kind of in this open-ended, possibility, like realm of possibility right now. And we have room for experiments, I think, even if it's in the standard library, as long as it works, we're not going to expose this as part of like the standard library interfaces to Go applications, right? It will be baked inside of Go. So if it needs to change, we can still change it, you know, in the next version of Go. It's not, you know, the constraints are not too strict in that regard.
Yeah, I agree. So do we assume like the generate bindings always have like a wrapper SDK on top of it?
I think that's
Look-
reasonable.
Yeah.
Like either the SDK or some standard library or some other something just to make them more usable. I think that is a reasonable
Yep.
I guess assertion claim to sort of put in the things to do, things to not do. Figure who we're targeting,
Or Go.
and then
Yeah, I agree. I agree
May-
with Ashil on this. Yeah. I do think, I think we also talked about evaluating the possibility of having the language specific bindings generated by the language in which they're
Oh
targeting.
yeah.
And I think that that would allow us to have higher quality iteration and faster iteration on the, say, the Go bindings, just specifically if the generator is written in Go than if it's written in Rust.
Yeah. Just want to elaborate on this point. For those of you who are not aware, I spent the night working on a hacking project to dump every internal structure of the weight parser into a JSON file, and you can write a Go program to consume that JSON file to build the Go generator completely in Go. So you can use, you know, AST library or any of the generator tools from Go to build that bindings instead of writing vast programs to emit Go strings of Go source code. And sometimes even that output program isn't even buildable. So have to spend a lot of time debugging that. It's not entirely maintainable. So I apologize that I completely messed up the time of this meeting. I was preparing for like a summarization of all the discussions from different issues, and I wanted this meeting to end with like a call for action and vote for different decisions we want to do for the Go economics improvements. Shall we move this agenda item to the next meeting, where I can, you know, give you better context and then we can make better decisions?
I think yes. I think also you can, from our discussion, I feel like the decision that we make today does, you know, probably will have to evolve. So it's fine, you know, if you think that one approach seems practical, I think it's fine to start moving forward with it, and and that might educate us, you know, on like what's the next blocker that we hit, or it might, you know, allow us to start, you know, using with ByteGen more and make more progress on the component model.
Cool.
Separate topic. I was curious if anybody's going to be at WASMCon, and maybe we could organize a meeting there of interested parties.
Yeah, I will be there.
Cool. Okay, we should totally do that.
Just next week.
Yeah, that's scary. I just realized I have to write a whole talk. Okay. So there's also a Componentize the World event. Is everybody aware of that? No? Okay, cool, great. All right, I'm adding value. So here is the event information. I don't feel that the Go tooling is necessarily far enough along to just like maybe we could run an event here where, you know, a table full of y'all folks, I think I'm going to be on the more on the Rust side, but of folks that are working on the Go side of things could try to hack and just co-work on some of this, I think would be pretty valuable. There's a lot to be done and there's a lot to learn, and just being in the same space as everybody else that's trying to solve the same set of problems, I think will help accelerate a lot of the work. That's sort of the idea of it.
Yeah, sounds great. Do you know what time it's going to be?
Yes, it'll we'll be kicking it off around 9 a.m. Alex Crichton is gonna kind of talk through some of the tooling that's there, WASM tools, bindgen, that sort of stuff. We'll get a tutorial from Joel Dice and Guy Bedford talking through some of the other language tooling that we have. And then it's kind of, we disperse into different working groups. Another aspect of it is that there is going to be a documentathon of sorts, and that there's a lot of documentation that needs to be written too. And so there's going to be a group of us, probably also me, working on that side of it. But I do know that we've got a couple different breakout rooms to try to give folks that are working on similar things enough room, and tables and outlets and all that kind of stuff.
Amazing. Guess we'll see each other there.
All right, before the meeting ends, I guess one of the biggest question in my mind is like the priority of things. As you may see, we have a lot of issues on the Go generator. We have the ergonomics improvement. We have removing SIG task. At the same time, we also have the request to write the generator in Go. So if we are going to parallelize the work, what do you think, which one should? I'm guessing if we want to write the Go generator rewrite completely from scratch in Go, we should probably do this first. And then while we are developing this generator, we incorporate the decisions from the ergonomic improvement, as well as not writing that using SIGO.
That sounds great to me.
So should we prioritize making JSON format? And
yeah, I agree with Randy that enabling more contributions is going to accelerate, more than figuring out just right interface. If only a few Rust friends are able to to participate. So I would support this timeline.
Yeah, I think sort of seeing the discussions and the issues that you created, Joe, I think that was a really robust conversation. I'd almost like to see that manifest itself in pull requests, so we can actually see how these various approaches might actually work concretely. I think that would that would speed things up quite a bit.
All right, so I will shift my focus entirely to the improving the JSON output from the wait parser, and I'll work with you, Randy, on getting the first draft of the Go generator in Go ready.
Cool. Yeah, I'm happy to work with anybody else on that too.
I can probably be available to help with that as well. So it's there's lots of hands.
Joe, I'm not sure if I don't have a dog in the fight here. It just wasn't obvious to me if it was if it's the JSON format that's key, or if you had a WIT parser library that was in Go that gave you access to all those structs in a native way versus a JSON structure of those, if that is a better option. I don't know if that has already been evaluated and eliminated. I shared what the TypeScript community is doing, which is writing their own version of these. is the summary of that. So this is definitely a pattern that I'm starting to see emerge in a lot of the different language ecosystems. And I think it kind of makes sense, honestly, at least for the WIP parser. I know it feels like duplicated work, but in theory, you've got the same AST, and so you can leverage a lot of that for your grammar parser, and do it in some of your native tools. If that way you get a slightly better API to work with, because then you're going to use other stuff on top of that. So anyways, I didn't know if that had already been decided for, writing your own WIP parser.
Well, I mean, there is no shortage of like parsing and lexing tools available in Go, but I think at least for getting a prototype working, it seems like using the JSON blob like is a good way to go. And then once we're happy with the generator that comes from using JSON, then we can say, okay, we can actually remove that and we can now generate our own thing that is parsing the WIT stuff and generating the equivalent data structure. But I think for getting a prototype up and running, let's just start with the JSON blob that we have and go forward with Go doing the generation stuff.
Yeah, Bailey, to specifically answer the question why, as this is my understanding, the idea of using, say, like the JSON intermediate representation, that's the fully resolved WIT file with all of its dependencies, and then that relieves the burden of having to duplicate all the dependency resolution aspects from the individual code generation. And so if you have a fully formed resolved tree, then you can just go generate code from that, as opposed to having to write a parser and then the resolution and then duplicating a lot of stuff that might not necessarily be, it might be worthwhile having in multiple implementations, but is it necessarily the best use of everybody's time, I guess?
That all makes sense to me. From my perspective, I like seeing different implementations crop up right now, because that means we're starting to harden the spec. One implementation does not mean it's a good spec. But now that we've already seen several of those, I'm not going to push for that anymore.
Yeah, one of the thing that confuses me is the name of the WIT parser, although it's called a parser, but it's actually doing more than you thought. It's resolve all the dependencies and even foreign dependencies from like a register, and all of the syntax wrangling and importing, exporting. It's doing a lot of work. Anyways, one more point to elaborate on that is we have discussed a third way. Well, the first way is rewrite WIT parser in Go completely from scratch, and we can then use the Go library to rewrite the Go generator. The second approach is emitting JSON from WIT parser written in Rust, and then consume that JSON to write Go generator. There is a third approach proposed by Lan from Fermion. He suggested to turn language generators to Wasm components by defining the generator interface as WIT packages. And obviously, without generators, this is like a circular problem, right? If you want to generate Wasm component, you need to have generator, but if generator are represented as Wasm components, how do you get those generators in the first place? So there must be some bootstrap code or hard-coded bindings for generator interfaces. And then we use that to generate Wasm components. And because of language agnostic, Wasm components can be written in different languages. And we got that for free. But that's like a long-term goal. I don't know how feasible that is right now.
It's a great dogfooding exercise. But maybe the problem is not big enough to justify the complexity in that case.
Well, I know the protobuf generator is written in protobuf. Is that right?
Oh, really? I didn't know that.
Like there is a protobuf interface representing all of the syntax of protobuf.
Well, the individual tools communicate in a protobuf defined API.
The plugin system, I think it's
Yeah, the
important.
plugins. Yeah, that was what sort of inspired the notion that like WIT bindgen generators should be written in a target language. Was something I work with protobuf stuff.
I mean, regardless, right, you still have to figure out how you want this to be generated. So I imagine that solution ports to either one. I guess it's the boundary where you have to, where you would be either using, yeah, some generator WIT definition versus what you come up with here. But knowing that that's maybe a future state, maybe will help inform the design as you start on, it sounds like you're going with option number 2.
Yep, for now.
Cool. All right, we are a little bit over time, but it was a lot of amazing discussions. Feels like we made some progress, made some good connections. Next instance is in 2 weeks, and Joe and I will put together the agenda for that. And that's it. Thank you everyone for participating, and we'll see some of you at WasmCon and some of you online.
Yep. Bye.
Thanks everyone. Bye.
Cheers.
Thank you.